All right. Well, this week I thought that I would help out with the homework a little bit by doing some of the homework problems for you. You were already given the answers, and I found that some of these are conceptually pretty difficult given the material that's already in the lectures on the rest of the course. And I thought it would help to go through my process for how I would solve them. So the first one, actually I'm going to skip number one because it's a pretty conceptual question. Um, so number two asks you to calculate how much heat must be removed from a 1 kilogram bucket of water to cool the water completely from 30 degrees C to 0 degrees C. So we got a temperature change from 30 Celsius to 0 Celsius. We've got a 1 kilogram bucket of water. We're going to be removing heat. And the answer that we're going to end up getting is 126 kilojoules. So on page 15 in the online materials, there's some stuff about heat transfer processes. And you see there that the heat flow, or the heat transferred, is denoted by the letter Q. Heat flow. So that's always an amount that's changed or transferred, is equal to the mass that you are changing the temperature of times the specific heat of the material times how much the temperature changes. So the M is the mass of the material. The C is the specific heat. And the specific heat measures how difficult it is to change the temperature of that material. So a high specific heat means it's hard to change the temperature, and meaning it takes more energy to do it. And a low specific heat means it's easy to change the temperature of that material, which means it doesn't take very much energy to change the temperature. So things like metals, which are good conductors of heat, have pretty low specific heats, and things like ceramics and water and materials like that have relatively high specific heats, meaning it's difficult to change their temperature. And delta T is how much the temperature changes. All right, so I want to find out how much heat flows. I know the mass of the amount of water I'm changing the temperature of. It's 1 kilogram. So I've got the Q that I'm looking for is 1.0 kilograms times the specific heat of water, which I would need to look up. So the C for water is 4.18 joules per gram degree Celsius, which is an interesting combination of units. So that means every gram of water that you increase in temperature or decrease in temperature by 1 degree Celsius requires 4.18 joules. So 4.18 joules per gram degree Celsius, and I'm multiplying between there. And then I've got a delta T. The delta T is how much the temperature changes. Well, it changes from 30 to 0. So the final temperature is 0, and the initial temperature is 30. So the change is a minus 30, and that's in degrees Celsius. All right, so I could just multiply this out, but the units don't quite match up right. I've got kilograms and grams. I've got degrees Celsius, and joules. Okay, so I'm going to have to do a little bit of unit conversion. I can see that the degrees Celsius and the degrees Celsius are going to cancel out. So I think all I need to do is I need to change the kilograms into grams, or vice versa. So I'm going to do the kilograms into grams. So I've got 1.0 kilograms times 1,000 grams in 1 kilogram times 4.18 joules per gram degree C times minus 30 degrees C. All right, and let's cancel out those units and see that it all works out. So the kilograms and the kilograms are gone. The grams and the grams are gone. The degrees Celsius and the degrees Celsius are gone. The only unit that's left is joules, which is a unit of energy. And heat flow is a measure of how much energy has flowed from one part, from one system to another. So let me move a little bit. So I'm going to have to multiply 1 times 1,000 times 4.18 times minus 30, and that will give me my result. So let's see. So I want 1 times 1,000 times 4.18 times negative 30. And you get negative 125,400. Okay. Negative 125,400. Come back over here and write that down. So that's equals negative 125,400 joules. And let's think about that for a second and compare it to the answer up here. This has 126 kilojoules. 126 kilos, 126,000, so that's rounded a little bit. So that's about negative 126 kilojoules. Why is it negative? Important question that you should think about, and you should explain this in your answer. Why is it negative? It's negative because it's a heat flow out of the water. When you cool the water down, you're taking heat out, so energy is leaving the water. If it was a plus, that would be a heat flow into the water, and that would be exactly the same in order to figure out how much it costs to raise the temperature of the water. And the sign of this would flip to plus. All right, I'm not going to finish B. I want you to be able to do that one yourself. I'm just going to tell you what you need to know. So in order to freeze the water in the bucket completely, the answer is 334 kilojoules. There's another concept you need, which is that when you're changing the state of a material from liquid to solid, or from liquid to gas, or from gas to liquid, or from solid to liquid, any of those phase changes, you get the temperature doesn't change for quite a while because all of the energy goes into breaking or forming the bonds in the ice, or breaking or forming the molecular attractions in the liquid. And so there's a specific, it's like a specific heat that determines how much energy it takes to change the state of the material. So for water, so this is for part B, part B. For water, it costs 334 joules for every gram of water to freeze or melt water into ice or ice into water. So what that means is if you're freezing it, you have to take away 334 joules for every gram. And if you're melting it, you have to put in 334 joules for every gram. So you're going to need to use that fact in order to figure out how much energy it takes to freeze that 1 kilogram of water. And you should find that it matches with the number up here, 334 kilojoules.